Hi, everyone. Thank you for coming. It's actually the first big conference I've done in a few years, and I forgot how fun it is to do these. I also forgot how important it is to take care of feet and voices. So good reminders. I didn't do so well yesterday, but hopefully we'll be fine for this talk. A little bit about myself. Stephen Bazyl. I'm part of the Workspace developers Google developers relations team for Workspace. Been at Google for coming up on about 14 years in about 2 weeks. So happy anniversary to me. And most of that time has been on Workspace. I've been working on Workspace APIs before it was even called Workspace, going back to Drive V1 and Docs List and some APIs that don't even exist anymore. And I love talking about authentication and authorization because one of the common threads that runs through Workspace APIs, which is a little bit different than other APIs at Google, is Workspace data is usually owned by users. It's owned by users and organizations. And so getting permissions to deal with access to data is a little bit more complicated, a little bit more frustrating sometimes than what you might see with APIs like Maps or GCP services, where an API key might be sufficient to do what you need. But Workspace isn't really my first foray into identity and access management. Prior to working at Google, I spent about 7 years at RSA Security, had worked on identity and access management there as well, worked on some technologies that actually became the precursors to what we now know as SAML and some other protocols. So this has been, for better or worse, a 20-year part of my career dealing with identity in some way or another. And even though it's not necessarily the thing I focus on these days, it's still a topic that is near and dear to my heart, and I'm happy to answer questions and help people after this talk. There we go. So in terms of what to expect, so authentication and authorization are huge topics. These are not things that we can cover comprehensively in 45 minutes or even a day. There's entire conferences that you can go to and learn really, really in-depth stuff about authentication and authorization. So for today, as the title of the talk implies, I want to take a look at authentication and authorization for Workspace from the lens of a developer. Right? So there's some information, some data in Workspace that you want to work with as a developer, and how do we do that? And the way we're going to do that is we're going to actually look at 4 of the most common scenarios that you would encounter. There's going to be some that we're going to ignore, but I chose these particular 4 because they're fairly representative of the most common use cases. And some of the ones that we're going to not really pay attention to do fit into these buckets in one way or another. And what we're going to do is we're actually going to start with a really, really simple problem statement, hopefully really trivial. And then we're going to take that application, we're going to morph it, add new requirements to introduce new concepts and new capabilities until we get to something that is something going from as simple as AppScript to something that you would see more in an enterprise IT use case. All the code, there are some live demos. All the code is available on GitHub. You can feel free to take a look at that later. If at any point you can't read anything, everything will be available for you to read. So I want to start with a really, like I said, a really simple problem statement. And since I spent a lot of time working on the Drive APIs, I decided to pick Drive. It's also one of the most popular APIs for Workspace. So we're just going to do something really simple. Just list the 10 most recent, and by recent I mean most recently modified. Doesn't really matter for this use case. And we're going to do that. And I want to start with the easiest way I know how to do this, which is with AppScript. And how many people use AppScript? OK, so about a quarter or a third of you. For those who don't use AppScript or are maybe not aware of what it is, it's a cloud-based JavaScript runtime that just has really tight integration with Google Workspace. And our architecture, and I'm using architecture very loosely here, is we have a user, it calls a script, calls a Drive API, and that is it, right? This is, when I say trivial, I really meant trivial. Like, this is the entirety of the application that we're going to run. And the nice thing is it actually reads very similar to the problem statement that we set out, right? It's call the files list API, sort them, descending order for modified, limit to 10, and print out the results. So you might wonder, if this is to talk about authentication and authorization, why is there no mention of authentication and authorization in the code, right? And the reason is there's a lot of heavy lifting that AppScript does when it comes to dealing with user permissions and identity and so on. And if you take a really naive look at that code, right, it raises a ton of questions, right? Like, whose files is it going to ask? Is it the person who wrote the code, the person who's running it? What else could that script do? Right? Like, how do we know if it's safe to run? If maybe I didn't write it and somebody shared it with me? Like, I would be really worried about just trying to understand what limits are actually placed on that bit of code. So we're going to we'll run that code. We'll see what it does. And then take a look underneath the covers to get a better understanding of what's actually happening. So this is the AppScript IDE. For some of you, this will be really familiar. But you can see the same code that we had up on the slide. And I can run this code. And the first thing it's going to do is actually going to ask me for permissions. Right? So for hopefully obvious reasons, we don't want to just run code that can do anything I can do, right? That would scare me a lot as a user. So we're going to see what it's going to ask for, and we'll review the permissions. And here we do. We have to choose a count. This is so we know whose files we're actually going to be accessing, who's granting the permissions. And what it wants to do is do everything in my Google Drive. And that's actually a fairly broad set of permissions that I'm granting it. Like, I have a lot of stuff in Drive. I don't necessarily want to share everything with a script, but for the demo, we're going to do it. Keep it here, and we'll talk about why this matters a little bit later on in the end. But for a demo purpose, I'm fine granting the script access. And once it's done, it just prints out the files, just as we expected. So, in terms of those questions, right? Like the way AppScript works is, AppScript is an authenticated environment. Right? It knows who I am because I'm logged in with my Google account, and every script I run needs to be granted permissions in order to read my data. The way all this works underneath the covers is using two standard technologies that you would use in your own applications if you're building on any other platform. And this is mainly OAuth 2 and OpenID. And you can think of OpenID as just an extension of OAuth 2, just focused on user identity. So OAuth 2 gives you a way to for a user to grant permissions to an application to access some of its data, grant it certain permissions. OpenID extends that notion to that data being their identity, right? What's my email address? What's my profile picture, my name, things about me, right? As opposed to data that might be in my Gmail account or Drive or so on. But they're very related, and they form the foundation of how AppScript and how applications in general, when you're working with Workspace APIs, work. So kind of the best way to understand this is we're going to take that same application and we're going to remove the support that AppScript was giving us. So AppScript did a whole bunch of work in terms of knowing who the user was, requesting the access for us, managing where all that is stored and how it's passed into the APIs. So we were left with a very, very small amount of code. If we want to do this in an environment where we don't have that luxury of what AppScript is providing, we have to do a lot more work. So we're going to change the statement. We're going to say 10 most recent files, but I want to do it as a web app that I can deploy anywhere. Right? And this could be on Firebase or AWS or Vercel, pick your hosting platform of choice. And since AppScript is JavaScript based, we're going to keep this in the same family of languages. We'll just do this as a client-side web app. So our architecture is pretty similar. We have users, we're going to talk to some application, and that's going to talk to the Drive API, but we're introducing a few new components into this architecture. All right, so we have obviously a server. AppScript was sort of previously doing this for us. It was our runtime environment. Now we need our own. It's going to be a server and a browser. And we need some way to recreate what AppScript was doing. Right? So we need to know some way to basically get permission from the user in order to access their files in Drive. And for this demo, we're going to work a little bit backwards. I'm going to just start, I'm just going to run the code. We can actually see this doing the exact same thing that AppScript is doing. And then we'll deconstruct it a little bit, and then kind of see how how it all comes together. So this is this code on Replit. Again, it's a pure client-side web app. And if I click fetch files, we have a slightly different UI just because I had to implement more of the stuff that AppScript is already providing us. Grant access, and we're going to grant it access to read everything in Drive. Click continue, and we get our file list. So, exact same app in terms of functionality, but we've removed AppScript from the picture and recreated all of the infrastructure it was providing. And just to show you like the kind of two important parts, if you were to look at this code on GitHub, a lot of this is really just UI-related code. It's simple app using Lit, which is a great framework for lightweight apps. But the important parts are this fetch file list. We do have a JavaScript client library. Decided to keep it limited to just using the fetch APIs, just so the code is a little bit more verbose and a little bit more explicit about what's going on. But we're doing pretty much what we were doing in AppScript. Right, so we have our parameters to our search. We're using modified time, limiting our results to 10, calling the Drive API. But where it starts to differ is we start introducing some new concepts. Right, so we have this thing called an access token. Right? If I were to just call the Drive API with no authorization header, it wouldn't know really anything about that request in order to answer it. Right, it wouldn't know whose files it's listing, which application, or anything. So we need some way to communicate that information about the user and the application and what it's allowed to do. I mean, the way we do that is via this access token. And the rest of the code is just error handling and response parsing. So the question is, where do you get this access token from? Now, the simple answer is we ask for one. To do this code is using the Google Identity Services SDK for JavaScript. This is a relatively new library in the last couple of years. It actually makes getting OAuth tokens or access tokens pretty much as simple as you can make it. It handles a lot of the plumbing with the UI in terms of doing pop-ups, tracking whether or not the user closed it, and so on. So really, the only bits of information that we need to provide are something called a client ID. And this is what identifies our application. And we have to describe what data we actually want access to. Right? And that is via a mechanism we call scopes. So in this case, I'm just saying I want read-only access to everything in Drive. Once we do that, we have a callback. So once the user gives us consent, we get what we call an access token. We get back an expiration time. Google access tokens are limited to 1 hour. And they will actually expire. Unfortunately, the expiration time comes back in the number of seconds remaining. So we have to do a little bit of date math in order to convert that into a more usable timestamp that we can check later on. Knowing 1 hour in the future at any point is not really useful. But once you do that, we can return the access token. And when we're ready to request, we just say request access token. Right? And that causes the pop-up to appear that we saw when we ran the code. So this raises a couple questions like, OK, well, kind of get access tokens, but there's a lot more to them, and also like how you actually get the client IDs and set up all these projects. And we'll switch over here. And I'll just talk a little bit more about those. So like access tokens actually they pack a lot of information into those tokens, right? They're not just, it's not the equivalent of a password. They actually bind three unique pieces of information that we need in order to answer API requests, right? So it's who's the application, right? Is this is this Asana? Is this Miro or Lucidchart or something, a script that somebody wrote? We need to know who the user is, the subject. Sometimes you'll see subject or principal. There's a few different terminologies you'll see when you're looking at authorization docs. But this is basically who is the user that this is bound to. Right, so when I authorized, that created this permission for this application to run on my behalf. And then the last thing we need are the scopes. And these are the things that say, like, what are we constraining this application to do? And also, like, often refer to OAuth as not necessarily an authorization protocol, but a delegation protocol. Because the permissions that I'm granting to the app are a subset of the things I can do. I can never grant the application any more access than what I naturally have. And my natural permissions are going to change over time independent of when I authorize that app, right? So it's always going to be like, what is the current set of files that I have access to, as opposed to a snapshot of the files at any given point in time. So these are access tokens. These are the magic keys. They're also considered bearer tokens, right? So which means if you have one of these access tokens, you are affected, like you can call those APIs. You don't need any other proof of that you are authorized other than that string that you can pass in an authorization header. It's one of the reasons why they are time limited to just an hour, because they are very powerful things to have. So you always want to make sure that they're transferred over secure channels. All the APIs only accept TLS encrypted traffic, and you just want to make sure that you're not leaking these in ways that things like putting in like query parameters or things that might leak in logs or proxies or anything like that. So in order to actually make all these requests, we talked about a client ID, and so how do you get one of these client IDs? Well, it starts with cloud projects. And for those of you who are in kind of the AppScript world, if you've only ever done AppScript, you might never have done this. But AppScript has done it for you. Every time there's a new script created, AppScript will actually create a GCP project. It will turn on a whole bunch of APIs, fill out a whole bunch of information about your application, create client IDs, and it does that automatically every time for every script that you create. So every script is its own unique little isolated application. There are times in AppScript where you might want to do this manually, or if you're doing it without AppScript, again, you also have to do all this manually. But the three things that we care about for Workspace is turning on APIs, right? This is just a signal for quota enforcement, things like that. Just we know which APIs your project is using. Client IDs, you can think of these as the credentials for your application. They think of it as like a username and a password for your app. And then the consent screen is branding information for when we ask the user for permission. It's how you signal to the user who your app is and why they should trust you. All right, so it includes things like your icon, your app name, contact information, but also things like your terms of service and your privacy policies. And if you're just building something for yourself, or you're building something for your own organization, obviously a lot of that doesn't really matter, right? Like, do you care what your own terms of services are? No, right? It's just your code, you're gonna run it. But if you're building something, if you're a software vendor and you're building an app for commercial purposes, you're gonna have customers, then this stuff starts to matter. And we'll talk a little bit more about what that, why it matters towards the end. And so I said, earlier, we kind of looked at this backwards. So I kind of want to like go back to the beginning of that process of like how you would actually build the app that we started with in AppScript from scratch if you were doing it in a different environment. And so it starts with creating a project, doing your consent screens, creating your client ID, turning on your APIs, writing your code for OAuth, calling your APIs, and you're done, right? And then you have a functioning app, and you're working with like Workspace data, whichever API, if it's Drive or Gmail or Calendar, it doesn't really matter. And the kind of the awesome stuff with AppScript is you get to jump to the front of the line, right? Like you're skipping almost every step, and you're just going to write code and done. So I love AppScript for that. This doesn't mean you should all just like jump on AppScript and use it for everything. It has its limits. But for just quick and dirty, like I just need to do something with my data and automate something, it is a really wonderful solution that saves a ton, just an unimaginable amount of time. All right, so one of the limitations of that version of the app is the flow that we used to get the access token was something we call the implicit flow. And it's really, really great if you just want an access token right away. But the problem is that that application only works when the user is using the application. And for a lot of use cases, that's totally fine. If you're doing suggesting content to link to a project, right, and you just want to show, hey, here's the most recent files that you might want to create a link for, right? Totally makes sense to do it in a way where you don't need anything more than short-lived temporary access. But there's a lot of other cases where that's not enough, right? You're doing batch processing, auditing, compliance, backups. There's a whole world of use cases where you need to be able to access that data anytime, day or night, for long periods of time, without having to have the user interact. So there's a different flow and a different mechanism in OAuth where we can ask for long-term access. And so we're gonna change that. We're gonna change our use case to say, well, we're gonna, instead of just going to an app and printing out the list, I want to get an email report. And in this code, we didn't actually implement the email reports because I don't want to, demoing, let's wait till Thursday at midnight to get an email. It doesn't make for a great demo. So it's going to be the same UI, but we're going to change the structure of the app and the code to mirror what we would do if we need this sort of offline batch processing. So this is our updated architecture. It's pretty similar. The main difference is we're adding a backend, right? So we need to run code in some secure environment, somewhere where the user is not going to be involved. And because we're going to start storing more information, we need a database. We need to store which users have signed up, what their email address is, and store these tokens, right? We need some way that we can call those APIs later on and some place to keep them. And before we go into the code, I just want to talk a little bit about authentication, because it's a little bit of a weird topic to talk to, because on one hand, if all you care about is access to the workspace data, it honestly doesn't really matter how you choose to authenticate your users, right? And you have a ton of options, right? Like, you can do it the way everybody's been doing since the beginning of computer time, and write your own username and password management system and store hashes and have your account recovery form. I would strongly discourage anyone from doing that. I would be very happy for the rest of my career if I have never written another login page in my entire life. It is just unnecessary, and it comes with a ton of baggage from just a security perspective, from an operational perspective. There are much better options. And I'll talk about the option that I chose in this demo. I'll talk about why I actually chose that. More likely what you're going to want to adopt is either a federated approach or using something like what we call auth as a service. So in the federated approach, it could be OpenID, it could be using Google sign-in, it could, SAML, if it's in more of an enterprise use case, is pretty widely used. It doesn't really matter which particular one, right? Maybe it's even just using talking to your LDAP server. All of those are totally fine. And then if you want to just sort of offload a lot of that work, auth as a service, I'm talking things like Firebase, Cloud Identity, Auth0, Supabase is another similar to Firebase in terms of functionality. And these basically take that vertical slice of everything around authentication, user management, recovery, federation, working with multiple providers, and just packages it up in a way that just makes things so much easier. So for this particular demo that we'll do next, we do need to add authentication, and because this particular application is really only designed to support your Google users, I'm going to use Google Sign-In, right, which is basically an OpenID-based approach. And it's just the least amount of code that I needed to actually solve this particular problem. And that's really the only reason I chose it, right? If I needed more functionality, I probably would have looked at something like Firebase or Cloud Identity as a more robust solution to handling how I authenticate users. All right. So we're going to go switch to this demo. Let's see. All right. So slightly different experience this time, right? So instead of just going straight to an authorize or list files button, first thing it's going to do, this is actually using Google One Tap. So this is automatically, as soon as the user hits the page, going to ask for hey, we see you're a Google user. Do you want to sign in, right? And it's an extremely expedited flow. Doesn't share any information with the application other than basically my basic profile information. And once I give it consent, that code's going to sign me in. It's going to create a session like we would do for just about any web app, regardless of what authentication method we chose. And also change the UI a little bit in this case. So we have 2 buttons now, right? Instead of just one button that does everything, I'm going to split the authorization. It's exactly the same as what we saw before. The difference is when we look at the code, the actual mechanism for how this is all working is a little bit different. So once you grant, we can hit fetch files, and same thing as before. So same application, same functionality. The main difference that we added this time is we added authentication, so we know who the user is. And we implemented a different authorization flow for OAuth that gives the application long-lived access. So I can come back come back tomorrow, hit the list files, and it's just going to work. I don't have to give consent again. So long as I'm logged in and knows who I am and it can get my tokens, like it will work. And it will keep working indefinitely until me as a user decides I want to revoke access. And there's ways you can do that in your Google account security page. But now, like this can send me emails, every day or every week, whatever my schedule is, and I don't have to think about it or worry about it. So there's a couple of bits I want to take a look at. Take a look at sign-in. So the nice thing is Google Sign-In, since it is based on OAuth, it's the exact same, all the setup that we did for setting up our client ID, for OAuth, filling out our consent screen. All of that just automatically carries over, right? It's the same client ID, it's the same application. I don't need to do really any other additional work other than using a different method basically to say can you log in the user? So where we had this token client before, we could say Google Accounts ID prompt, and that's just asking the user, hey, log in this user, let me know when you're done. And what we get back is what we call a JOT. It's a JSON web token. And what this is just it's a little blob of JSON that has profile information about the user. It's signed, verifiable, and we'll take a look at that code of what that looks like. But without having to know the user's password or really anything about them, the app can just get this verifiable token and then convert that into whatever credential format it needs internally, right? Maybe you can use a JOT as a session token. In this case, I'm just using cookies in my own session. We have a lot of different options for how this all works. Let's go to, okay, so there we go. Yeah, so this is basically the verification for when we get that JOT. We're just going to, this is the backend code now. This is not client side. This is just a Express.js route handler. So when a user signs in and we get that JOT, there are some things that we have to do from a security perspective. We'll talk about that in a little bit after this. But hopefully things like cross-site request forgery preventions are hopefully familiar topics. If not, we can talk about them. Happy to answer questions. But we're just using this is the Node.js auth library for our API clients. It actually has a built-in method for verifying the token. So I don't really have to give it much other than the token itself and our client ID. Right? And that's actually really important for making sure that attackers don't give us don't mint their own JOT for their own app and try to confuse who well, yeah, just because I signed into app A doesn't mean I can sign in for app B. So that's really the bare minimum for what you do. The library does a lot of other checks in terms of checking expiration times, checking the validity of the signature. So most of the time, you don't really have to get into any of the nuances of how JOTs work or the encryption or signing methods or anything like that. Just use the libraries. They work great. They'll do the checks and make your life just a lot easier. And then once we do that, we have we have some information. So in this case, this subject is user ID. We have the email name and avatar photo from Google, and we can use that to just make the app look nice. For authorization, very similar. It's actually very similar to what we saw before. But instead of calling this init token client, we're calling init code client. And this just is an instruction to the library that we want a long-lived grant and a long-lived token that we can use for our app indefinitely. The difference in these flows, from a UI perspective, almost indistinguishable. Right? And just doing that demo, you couldn't really tell which flow was which. From an implementation perspective, the difference is that instead of getting an access token back that we can use immediately, we get back an intermediate value. We get this, what they call an authorization code. And what we need to do with that code is then send it to our backend, send it to a more secure environment where we can then turn around and exchange that for both an access token and this new type of token which we haven't seen yet, which is called a refresh token. And that refresh token is the thing that we need to save. Right? That's the thing that we can indefinitely, every time we need a new access token or need to call an API, we can take that refresh token and ask Google, give me an updated access token that I could use right now. And there's a little bit more security around that. It's part of the reason why you have this a little bit of an extra balance in how this all works. But really, the code is almost the same. We just, as soon as we get that code, we're just going to forward it to our backend and then process it there. So you got to see what that backend code looks like. It's this exchange code method. So other than doing some request forgery protections, we're just going to use the client library just like we did before for verifying the JOT. We're going to give it our client ID and client secret, which we get from our GCP project. And then we exchange that for our tokens. And then once we have these tokens, because these are long-lived, we want to hold on to them. This is why we need our sign-in and our database. We want to just make sure that we save those credentials in a way that we can associate them with the user in a secure way. But once we've done that, we're good. Like, we can now call APIs for anytime we want for that user until our access is revoked. And our list files method is actually pretty similar. Instead of, we've moved this to the backend. Right, so we're not running in the client anymore. We just have similar logic. We're just going to load our credentials from the database. We're going to check to see if our access token is expired. Again, these do expire every hour. If it is expired, we just need to call this refresh access token, right? And so long as we're providing in our valid client ID and secret and so on, we can just keep doing this anytime we want. Once we have that, we can. It's an optimization to resave the credentials and resave the updated access token. But then after that, the code for calling the Drive API is exactly what we had on the client side. Parameters, call it, pass the authorization header with the token, and we're done. And so it's almost the same thing. We just saw a slightly different way of getting those tokens, and that's it. But before we move on to the final use case, I want to talk a little bit more about security. And so you saw hints of that in the code. You saw some cross-site request forgery protections. There's a number of ways that you can go about protecting them. Some are very simple. Some a little bit more secure, but a little bit harder to implement. But when you have offline access, your app has a lot more capabilities, right? An access token on the client that expires in an hour, yes, it's bad if it leaks, but it's not the end of the world. That token will naturally expire and become useless, within 60 minutes. You still want to protect them as best you can, but a refresh token lives indefinitely, right? So if that leaks, if that and your client ID and client secret are exposed, right? Well, now an attacker they can do a lot more damage. And they're also, because of the differences in the protocol, there's actually some really unique attacks that attackers can do with basically unsolicited requests, right? Where I can begin the authorization process for an account I control, and then trick you into completing it and linking that with your account. And so most of the countermeasures that you see recommended with OAuth are really around making sure that the person who requests access is the same person who you're actually you want to make sure there's continuity throughout that entire flow, and not letting people start on one device, complete on another, because those are generally going to be attacks. Good news is they're actually really simple to implement. The majority of them are if you built a web app and you've dealt with cross-site request forgery. Same defenses that you would use for protecting a form, you would use for protecting your sign-in and your OAuth flows. There are some OAuth-specific mechanisms that you use in certain use cases. For sign-in, just making sure you validate JOTs correctly. There was actually a somewhat infamous vulnerability that came up not too long ago, where some libraries allow unsigned JOTs by default, so you can just make up anything you want. That's a pretty bad vulnerability if you can let an attacker just be any user at any time. First, a lot of things are fixed, and default behaviors are pretty good. And then obviously you want to protect secrets and so on. I do have a link to, there's an RFC on OAuth security threats and countermeasures. Again, you don't have to be an expert. You don't have to read through all of it. But it is actually really, if you like security, it's really interesting reading to see why the protocols work the way they do and why the recommendations are what they are. But when it comes down to implementing, you don't really have to do a lot. You just have to make sure you do at least the things that are strongly recommended by any provider that you work with. All right, so we're gonna do one last variation on this, and this is more for, now we're gonna get into more of the enterprise use case. So it's great, we have an app, users can sign up, they can get their reports, but now as somebody in IT, and I have to manage compliance for my org, I want to get whatever report we're generating, I want to do this for every user in my org, right? And well, yes, we could have them all go to the app and log in and sign up and give access, but once you get above probably a pretty small number of users, that becomes just impractical, right? And certainly if you're in an org of thousands to tens of thousands of users, you can't even have that conversation at all, right? So for somebody, if you're coming at this from an IT perspective, right, you need a way to be able to grant your apps and make these decisions on behalf of all your users without having them in the picture. So we're going to have a slightly, actually a slightly simpler architecture than we had for the other app. Kind of back to almost what it looks like with AppScript, where we have an admin is going to run some script, is going to talk to drive APIs. But the part that we're adding is this out-of-band process between the IT admin or somebody who's privileged enough to make these decisions. And then granting our app access via the management console for Google Workspace. So what this allows you to do is that, and before where we had client IDs, we're going to use a slightly different mechanism that is probably more familiar. Are there people who use GCP? Okay, so probably have dealt with service accounts, right? So you have service accounts, and that's kind of the primary way for GCP to use to do authentication, right? And it's just identifying who your application is. Very similar to what we use client IDs for in OAuth. It's just a stronger way of authenticating, right? You have public-private keys instead of just a simple symmetric key. So we're actually going to leverage service accounts and grant that service account the ability to impersonate all of our users in our organization. And just because I didn't want to have an unsecure service account with impersonation abilities running on Replit, I did wrap this in Google Sign-In just to make sure that nobody else is going to just hit this app and actually log in and try to impersonate all my test users. So it is guarded, but we don't have the authorization button anymore. I can just list files. And the way this works is, as an admin, I previously authorized this app to act as any user. So if I were to log in as another test user who's never even touched this app before, as soon as I sign in and hit list files, it's going to work. No permissions are needed because the admin has already made that decision. From a code perspective, it's actually pretty simple. Right, we use our JOT client, and we just add a couple extra claims. We say the scopes that we want, and we give it a subject. And that JOT, the same JOTs that we use for identity for Google Sign-In, we can exchange that much in the same way that we exchange the authorization code in the previous example. Right, so we just say, we go to Google Identity, the Google account services. We say, hey, on this app, I want to act as this user doing the scope. Give me an access token. And if that grant exists, if the admin went through the proper steps, you get back an access token, and then you can start using APIs just as if the user went through the OAuth flow themselves. You're just short-circuiting that entire process. There are a couple different variations for how domain-wide delegation works, depending on how you're using service accounts. In this particular case, I'm using a private key that I downloaded, right? So I can sign that. I can create the JOT locally, sign it, and exchange it entirely within the application. If you're running on GCP, if you're running on Cloud Run or Cloud Functions, a lot of the times you don't have the private key, right? It's somewhat discouraged to actually download the private keys these days. And so you have an alternative where you can actually do a remotely signed job. So we have an API, that's actually just called signed.jot, appropriately named. It's part of the IAM APIs. And so long as you have the service account token creator rule, you can call the API with the payload that you want signed. It will sign it. And then you go around and exchange that for an access token for that user. Your mileage for how easy that is in any particular language depends on the client libraries. Some of them make it really easy. There are a handful of the client libraries where that particular version of the flow is not very well implemented. So you might have to do a little bit of the work that was kind of hidden in the Node.js version. You might have to sort of break those steps apart and handle the exchange yourself. So we looked at like 4 different scenarios for this, and really like there's a whole bunch of scenarios that we didn't even talk about, right? Like a lot of this is going to vary depending on if you're building a mobile application, right? Like the flows on Android are a little bit different than they are on iOS versus a web app. If you're building a desktop app, right? If it's a command line versus or something built with Electron, all of these things are going to have slightly different variations to how they're done, right? But they all fit within these buckets, to some extent. But the main point is like how difficult OAuth is going to be and how much work you have to pay attention to security is really dictated by your use case. And really the thing is just to be lazy, right? Like that is my recommendation, is like really only do as much as you actually need for the problem you're trying to solve, right? And that's usually where I see developers get tripped up is they very often will jump to the most complicated way of doing OAuth when really what they need is much, much simpler. And depending on what you need to do, like if you're just tinkering around, do AppScript. AppScript is super awesome for a quick hack. If you're building a commercial application, you're going to sell it to lots of customers, and you need to scale, you're probably going to do something with implicit or code flow, right? I would not recommend domain-wide delegation for multiple customers. It's just a lot of security risk. Those are really only focused for internal cases. But really, most of the applications are going to be kind of in the middle. And it just depends on, do you need offline access, or do you need, if it's only for when the user is present. But that's really the main takeaway. It's just do the least amount of work recommended, right? Like that's it. So one last thing I want to talk about, we've got about 2 minutes left, is sort of the elephant in the room with OAuth. And I don't know how many people have actually gone through this process before. But there is an approval process for OAuth. And your experience with that process can vary wildly depending on a bunch of different factors. So the good news is, if you're just building something for your own org, or you're building something for yourself, it's easy, right? There's no process, there's no approval. It's your data, do with it what you want, and nobody cares. If you're building something for other users, you're going to sell it to customers or consumer accounts or schools or whatever, then it becomes a risk-based process, right? If you're just doing sign-in and all you want to know is who the user is, it's usually pretty easy, 2-3 days. Really, they're only looking at your branding information, do you have reasonable terms of service, privacy policy, and so on. And again, usually turn around in a couple days. If you're requesting data access, then that's going to depend on how much data you're asking for, right? So if you want access to just a little bit of information in Workspace, you might get by with a self-assessment, running some automated security tools just to check that things are OK. But if you're asking for like full access to everything in Drive, and you have a huge customer base, right? Well, that process might start to involve a third-party security audit, and the timelines could actually be on the order of several weeks to a month or two. The point of this isn't to scare you and say like, oh, like this really crazy process that I have to navigate. It's really not that bad, and the process has improved a lot over the last couple of years. It's really just to make sure that you plan for it, right? And so like if there's like three lessons from any of this, it's like understand your use case and be lazy. Security matters, but you don't have to be an expert, and just plan for the process, right? Most of the escalations I see like that come my way from partners and so on are really just that
nobody planned for this, the approval process, and so they're like, hey, we're going to launch on this date, and they just submitted their app 2 days before their launch, and then they get a whole bunch of feedback that's going to take them 4 months to fix, right? And like, that is not a situation anyone wants to be in. But if you, sort of understand the requirements early, you plan for the reviews, you plan for doing the security analysis, it's a pretty manageable process that, pretty much every developer I've ever worked through has successfully made it through, right? So like, don't be scared, just plan. So that's all I have, just a couple of things, last resources. I certainly encourage everyone to check out, in the Innovators Hive area, we have the entire Workspace developer relations team. We're happy to chat, answer whatever questions, or just learn about what you're doing. A whole bunch of other sessions. A lot of these have already happened, but you can check them out online. You can also sign up for our newsletter. It's a once a month newsletter you can sign up for. We just give you kind of what's new and noteworthy with any Workspace APIs. And of course, you can follow us on LinkedIn and Twitter and so on. And of course, as always, any feedback that you have on the session, certainly happy to have that. It would just help us make sure that we give the content that you need for future events. And that said, that is all I have, and I'm happy to answer questions or chat with people in the Hive section for the rest of the day or tomorrow. So thank you very much.